We are going to solve trig equations by factoring today. And when you're looking at equation, how you know you're going to have to factor is if you have different types of trig functions like secant and cotangent in the same equation, or you have different degrees of the same trig function, like a sine squared and a sine. So let's look at a few examples. Okay, so solve each equation for x between 0 and 2 pi. So we're in radians. Okay, so this is one that I know I'm probably going to have to factor because I've got cosecant and tangent. I have two different trig functions. So remember, anytime you are solving by factoring, it has to equal 0. Okay. Sometimes I see people, they'll want to divide through by this tangent and just get rid of the tangent. And you can't do that because you will potentially be losing solutions that you would get from that tangent equation. Okay, so if you ever look at an equation and you want to divide and cancel something out, what you really should do is move it all to one side so that the equation is equal to 0. And then I have a GCF of tangent. So I can factor out that tangent. So I'm going to have tangent of x. Here I'd be left with a cosecant of x minus 4. Remember, when you're factoring something out, you're dividing by this tangent. Okay. Sometimes it helps people to think of cosecant as maybe a and tangent as b. So if I were to look here, that would be a times b minus 4a. And so you would, again, just GCF out the a, and you'd be left with b minus 4. And then you can go back and put in your tangent and cosecant. So if it helps you to factor just by switching the trig functions to different variables, you can factor that way. Okay, and then once you've factored, you're going to set each factor equal to 0. So I will have tangent of x equals 0. And cosecant of x, I'm going to move that 4 over, so cosecant of x will equal 4. Okay, so since this is tangent, this is my opposite over adjacent, and so remember, this bottom number can be anything, positive 1, negative 1, any number we want. So if it's 0, what's on the bottom can be anything. Okay, so this is going to be quadrantal, okay, because one of the sides is 0. Okay, so remember, opposite goes with y. Okay, so tangent would be y over x. So I'm looking for where my y value would be 0, and that would be on the x-axis. Okay, so I would have, and you don't have to label the points anymore unless it helps you, but both of these, my y over x, would give me a tangent value of 0. So for the tangent equation, I'm going to get x equals 0 and x equals pi. Now cosecant, this will be 4 over 1. This is going to be my hypotenuse over my opposite. Okay, so this one is going to be triangles. However, they are not special right triangles. I don't have a special right triangle that has a hypotenuse of 4. Okay, so that means I'm going to have to use my calculator to solve it. So first, I got to get the reference angle. Okay. So anytime you're looking for an angle, you're always using inverse on the calculator. And there is no cosecant, so I'm going to use its reciprocal. I'm going to use inverse sine. Okay. And then if I look here, sine, opposite over hypotenuse, that's going to be 1/4. Okay. So on my calculator, I'm going to do inverse sine of 1 over 4. And that's going to give me my reference angle of 0.253. Okay, and since I have an answer in the first quadrant, that is going to be one of my answers. Okay. And then here in the second quadrant, I'll do pi minus my reference angle. And that's going to give me my second answer for the cosecant equation of 2.889. Okay. Now, there's one more thing I have to do. Anytime you get quadrantal solutions in an equation that has two different trig functions, you have to make sure that cosecant, so I got 0 and pi. I got these two answers from the tangent equation. Okay. What I have to do is I have to check that cosecant is not undefined at these two values. So at 0 and pi, remember cosecant The hypotenuse would just be 1 at these quadrantal angles. The opposite is y. Okay, so if I look at these two angles, if I do cosecant of pi, remember the answers I'm giving, they're answers to where if I were to plug them into the equation, they would make the equation true. So if I plug in 0, the first thing I would have is cosecant of 0. That would be 1 over y, which would be 0. Okay, so these two angles right here, since my y value is 0, they make cosecant undefined. So these are two solutions that are extraneous because they won't actually work if I go plug them in to the original equation. So the only two answers I get are these two I got from the cosecant equation off of the calculator. Okay. So let's just talk about when you have to check for these extraneous solutions. Okay. So it's only if it's quadrantal. Okay, so it's only if you get quadrantal solutions and you're solving a trig equation with different trig functions, like this last one had tangent and cosecant. Okay, so when you're solving trig equations with different trig functions, some quadrantal solutions may be extraneous because they make the other trig function undefined. Okay, so like for this most recent example from the tangent equation, I got 0 and pi. But cosecant is undefined at 0 and pi, so that's what made those two answers extraneous. Okay, so if I'm solving a trig equation and it has two different trig functions, okay, if I get pi over 2 and 3 pi over 2 as my answer, okay, and I've got secant and or tangent in the equation, secant and tangent are undefined at pi over 2 and 3 pi over 2, so I wouldn't be able to use these answers. And that's because, remember, at quadrantal, secant would be 1 over x and tangent would be y over x. Okay, so since x is 0 at both of these angles, that's why secant and tangent are undefined. Cosecant and cotangent, they're undefined at 0 and pi because both of these ratios, cosecant would be 1 over y, cotangent would be x over y. Well, at both of these angles, the y value is 0. Okay. And sine and cosine, those are never undefined. Remember, their graphs don't have asymptotes. That's because they are continuous functions. They're never undefined. So if your other trig functions are sine and cosine, you don't ever have to worry about those being undefined. So let's go ahead and look at another example like this. Okay. So solve each equation between 0 and 2 pi again. Okay, so I've got cotangent of x times secant squared of x plus 2 cotangent of x equals 0. So I've got two different trig functions. That means I'm going to have to factor. I have a cotangent and a secant. Okay. It's already equal to 0. So all I need to do is take out the cotangent, and then I'm going to have secant squared of x plus 2. And then once I've factored, I can set each factor equal to 0. So cotangent of x equals 0, and secant squared of x is going to equal -2. Okay. So on this one, I'd have to square root both sides, but that's going to be imaginary. Remember, we don't have any imaginary solutions in trig equations. So I'm not going to get any answers from this secant equation. Okay. Now for cotangent, cotangent is adjacent over opposite. So again, this is going to be quadrantal, okay, but this time I'm looking for where my x value is 0. Okay, because adjacent goes with x. Y can be anything. So the x value is 0 on the y-axis. Okay, so I've got quadrantal angles here, so I have to consider whether or not they're extraneous. So these two angles that I have are pi and 3 pi over 2. Okay, so I have to worry about the secant part. Okay, I don't have to worry about these angles working for cotangent. If I got them from the cotangent equation, I know that they're good for the cotangent function. I just have to think about secant. Okay, so at quadrantal angles, secant, remember hypotenuse is always 1 for quadrantal angles, adjacent is always x. Well, if I look at these two angles, the x value is 0. So secant would be undefined at these two values, so that makes these two answers extraneous. So from the cotangent equation, my answers were extraneous. From the secant equation, I didn't get any answers because it was imaginary solutions. So I have no answers that work on this one. So this equation has no real solutions. Now, let's say on this equation I had gotten like pi over 4 and 3 pi over 4. If you get non-quadrantal answers, you don't have to worry about the extraneous or not extraneous. It is only if you get quadrantal solutions and there's another type of trig function in the equation. The next thing we're going to go ahead and do is some trinomial factoring. And I am going to do that in the next video so that I don't get cut off midway through.